Alright, so this is going to be another video about using the first derivative to figure out where a certain function is increasing or decreasing, as well as finding all the extrema, whether it's relative or absolute. So we have this problem right here, g of x is equal to x times the square root of 8 minus x squared. First thing we're going to do, like we did the other problems, is find the first derivative. Okay, this derivative is a little bit more complicated than the problems we're just looking at because you need product rule as well as a little bit of chain rule in this. So f prime g would be f prime would be 1 times g, which is just that 8 minus x squared. And by the way, if you forgot how to do product rule, there's videos as well that kind of help review for this. If you don't understand what I'm doing right now, I would check those videos out. Okay, so that's f prime g plus g prime minus 1 from the half power, and then you have to multiply by the inner derivative of the 8 minus x squared, which is negative 2x, and then you have to multiply by f, which is going to be x. So you end up with a crazy derivative that doesn't really look very eye-appealing, and it doesn't look like it's going to be very easy to solve, because if you remember, we have to find the critical numbers, which means we have to set this equal to 0 or undefined. So I'm going to clean this expression up right here, this one in red, really quick, just to make it easier to be able to solve for those critical values. All right, so this is going to be a little bit easier to work with. I'm going to solve the undefined first. The undefined is wherever you're going to be dividing by 0, or if it's a square root of a negative, but we don't really need to worry about that for this problem. So we have right here the division by 0, which is where 8 minus x squared, so it's where this part right here is equal to 0. So the undefined would be equal to the plus or minus the square root of 8, which is plus or minus 2 root 2. So we have two critical values right there. Now we have to solve for where it's equal to 0. So what I'm going to do is add this expression right here to the other side, and you end up with the following. So you end up with this, and then this is you just need some algebra basically to solve this. So I'm going to multiply both sides by the square root of 8 minus x squared, and you end up with the following. All right, from here I'm going to add over the x squared and do some algebra to solve for x really quick. All right, so now we have all our critical values. We have plus or minus 2 root 2 and plus or minus 2. One thing that we have to take into account here is where the square roots are negative. In this case, the square roots would be negative if x was less than or greater than these two values right here, the square root of 8, which is plus or minus 2 root 2. So when we make our critical number line, we have to take that into account. So basically, you can't get any smaller than negative 2 root 2, and you can't get any bigger than 2 root 2 here. So it's going to be basically limiting our intervals here. We're going to have g prime up top, g on the bottom, and then you're going to have negative 2 and positive 2. Now we just need to test those intervals out using the derivative. I would use this orange part right here because it's a little bit easier to work with. So if we picked a value between negative 2 root 2 and negative 2, this value would be negative, which means g is decreasing. So a good value to pick for this is probably like negative 2.5 or so. If you plug that in there, you end up with a negative. And then I'm going to plug in 0 again to that orange right here, and you end up with a positive. So then it's increasing, and then the last one would be negative for decreasing. So from here, we need to write this all in interval notation. So I'm going to do that. We're kind of running out of room. I'm going to do that over here. If we sketch what our graph would look like here, it would basically be decreasing here, then it's 0, then it's increasing, and then it's decreasing there. Okay, so that means we would have a relative min here and a relative max here. So your relative min would be negative 2, comma. Now you have to plug it into the original up here, and if you did that, you would end up with negative 4. And then your relative max, which is this one right here, would be at 2, comma 4. Again, you have to use the original function to figure out those y values. And then we need to figure out the absolute min and absolute max. Now, since this is a closed interval, there will always be an absolute min and absolute max. So what we can do is we need to figure out what f of the endpoints are. So the f of this endpoint and the f of this endpoint would actually be 0 for each of them. And since 0 is going to be smaller than this value and this value here, the relative extrema are also going to be absolute extrema. So I'm going to write that in really quick. All right, so basically that answers the question. It got a little jumbled in here a little bit, but the increasing, decreasing would be this purple right here, what I'm highlighting right now in purple. The orange and the green here is going to represent your relative mins and relative maxes, which also happen to be the absolute mins and absolute maxes as well, respectively. So that's basically how to do another problem using the first derivative to figure out increasing or decreasing intervals, as well as relative and absolute extreme. If you have any questions about anything in this video, let me know.